Hello and welcome to JavaScript Marathon, a full week of free online courses in some of the leading web development technologies and concepts. Excited to introduce you to our very own Dustin Goodman, engineering manager at This.Labs. He will be presenting Serverless Framework 101. A bit about who we are at This.Labs proudly partners with enterprises interested in transforming their digital assets, upskilling their teams, and finding novel avenues for advanced integration. If you're interested in seeing some of the work we've done with our amazing clients, take a look at our portfolio page at this.co/portfolio. We are hiring. This.Labs is seeking a senior software engineer. If that fits your job description, send us your info at jobs@this.co. You can also see a full listing of all of the jobs that we are hiring for at the moment at this.co/jobs. We have a really busy June coming up. React Mentoring is on June 7th. Women in Tech Monthly Mentoring is on June 15th. And State of Web Components will be on June 21st. And with that, I will hand it over to Dustin.
Hello, everybody, and welcome to this special JavaScript Marathon. Today we have serverless training, and today we have Dustin Goodman who is presenting. Dustin, we're so excited to have you.
Glad to be here.
Yeah, it's going to be a ton of fun. Dustin has promised us like so many things. By the end of this, you will know how to invest in Bitcoin and make $100,000 with serverless. Right, Dustin?
Yeah, great joke.
I mean, I was stretching so hard, like trying so hard.
Sorry. I will show you how you can deploy to infrastructure, and if you know how to mine, you can abuse it probably, but
Well, there we
don't
go.
recommend it. Do not recommend it. AWS is very strict about it.
That is going in the event description.
Fantastic.
Okay. Well, take it away, Dustin.
Awesome. Well, very excited to talk to you all today. Specifically going to be talking more about the serverless framework, and not just serverless, but of course, we're going to have to talk about serverless before we even get to the framework. Kind of on the docket for today, we're going to talk about kind of what is the framework, what are serverless architectures in general, and then we're going to spend most of the time just building stuff, actually deploying to infrastructure, seeing how we can build functions, showing you all kind of the really cool features that we're going to have as part of learning what serverless architectures are and how we can use them. So to get started, what is the serverless framework? And I really have to start with, well, what is serverless? And it's this idea of a cloud-first development model. So traditionally, you have your server, you find like an EC2 instance, which is an actual server, you deploy it to there. You might put a load balancer in front of that, and then you might even use Docker or something to distribute to a variety of services. Well, with cloud, it's really more, there's managed servers with services that you can just plug and play into and utilize those to create large applications without having to worry about creating your infrastructure and maintaining it. Wow, words. And then creating the monitoring around it. So all this is kind of baked into the services for you. And one of the questions that people have been asking me recently is, but aren't there still servers involved? And the answer is, yeah, but you just don't care about them. They're fully managed by whatever provider you're using. So you can focus on shipping your code instead of working on provisioning, monitoring, and scaling those servers. And what's amazing is they auto scale. So if you've ever had to set up a Kubernetes cluster, you've had to create your orchestration and determine how things will scale up and down with traffic. And you don't have to worry about that in this environment. I mean, you have to worry about it from a cost perspective, but not necessarily from a active monitoring perspective. And what's really cool about the serverless model is it's an event-driven model. So when it's not in use, you're just not paying for it. So imagine you have this one function and only runs, I don't know, once a year. You don't have to pay for the hardware to keep that server running that code for the year. It'll just spin up for that once a year runtime. You'll pay the bill for it later. And it's honestly only pennies to the dollar most of the time. So it's also super cheap. So how serverless functions kind of work is you upload your function code to your cloud provider account. And this could be any of the cloud providers, GCP, Azure, Tencent, AWS. I'm going to be talking more about the AWS infrastructure because that's what I'm the most familiar with. And it's also what the serverless framework plays best with. Then what you do with that uploaded function is you set up some triggers, and this could be an API call. This could be an in-app click in whatever cloud provider you're using. This could be a queue, a DynamoDB update, a cron job. It can be another function triggering it. So there's hundreds of ways in which functions can get triggered. And this is where the real power is you're writing these unit testable code blocks that can then be used in a variety of ways that we just inherently can understand once we understand what the event model around it is. And so once you kind of define that trigger, you uploaded your code, your cloud provider will run your function and trigger that code in production for you at a later date. And it's just awesome how that works. So serverless framework, now that I've kind of defined what serverless is intended to be a zero friction serverless application development environment. And really what this boils down to is it gives you this amazing CLI and configuration toolset for creating your serverless applications. And what's really great about it is it's provider agnostic to a point. And what I mean by that is once you start defining resources and utilizing certain services, you're probably going to get locked into a provider at some point. But it's not at a point where you have to be worried about it too far up front. On the right here, this is actually all of the active providers that they support. So Azure, Tencent, Google Cloud, Cloudflare, if you're using those new workers, you have access to them through the serverless framework. So just look up the docs for it. But again, I'm going to talk more about the AWS again, because that's what I'm most familiar with. And that's also what I set up for today. And what's really additionally great is that these functions are supportive of you writing your functions in the language provided. Let me say that again. These functions can be written in any language that you choose, so long as your provider supports it. So AWS actually supports PHP, it supports Ruby, it supports Python and JavaScript. So you can actually use any of those languages. And I'll show you all a very simple Ruby example a little further down the line, but super simple to do. So there's kind of 5 key concepts that we're going to need to talk about while we're doing serverless. And I've put their equivalent AWS name if there is one that exists. So first off is functions, and this is going to be your code deployed to the cloud that does that single job. And that's going to be Lambda and AWS. We're going to have events, and these are going to be any of the actions that you want your function to be triggered under. So this could be an API gateway, an S3 bucket upload. If you're using SQS, this could be an SQS message. So these are going to be what AWS calls triggers. Then we're going to have resources, and this is going to be literally anything you need in the cloud infrastructure, and serverless can actually spin up those resources for you, distribute them, name them, give them the keys, values, anything you need. Then you have services, and this is just going to be an organizational unit for project files, which can be defined using a serverless configuration file. And you'll note there's 4 different ways you can find a serverless configuration file. You can use YAML, JSON, JavaScript, and if you put a little extra love into it, you can even use TypeScript, and there's good type support out there if you find the right file. And then finally, plugins, and these are going to be libraries that extend the framework to make it really powerful. And I'll demonstrate a few of my favorite plugins throughout this talk today. Let's see, I'm just going to read the questions real quick. Mark asked, is AWS serverless similar to Next.js APIs or Remix action functions? Conceptually very similar. Behaviorally a little different in how they're deployed, but in how they're not so tightly bound to the function, the framework, but yes. And then Alan asked, can you mix the languages used within a single application? The answer is yes, but only if they're in separate services. And I'll talk about that in a little bit as well. So serverless architectures. I'm just going to show this kind of quick example. This is a very, this is still a relatively bare bones example of what a serverless architecture could look like in the AWS cloud. It could get way more complicated than this. It could get way more simple than this. But to walk y'all through this diagram, your client group over here, so mobile devices, computers, they can go and hit the server either through an S3 or API gateway connection. We'll kind of ignore the S3 connection for just a minute, and we'll kind of focus on the gateway. So in the gateway path, what happens is, first off, you can set up what we call an authorizer function. And this says, hey, is this user or is this request that's coming in allowed to run any events on your gateway? So this could be any authentication, and this could be global to your entire API, which is really fantastic for just centralizing that logic. And then what happens is you use Amazon's API gateway to forward the request over to your Lambdas that actually execute the fetching of the data or manipulation or whatever you're doing. So in this case, kind of set up as an example where you might have like a get users or get user that get passed over, and they access your database, get the user, pass it back to the gateway, forward it to the user on the client side. In this other case, I have a post user just to show some other ways Lambdas can be triggered. So in this case, this post user actually triggers an event on another Lambda that could do something generic. Or alternatively, you can actually push into Amazon's simple queue service, or SQS. And then what that'll do is it'll eventually trigger a new Lambda to execute the function or the worker. Additionally, you have this fun little situation up here where you can run cron jobs. So let's say you don't want something attached to your API. It doesn't actually have a real trigger, but you need it to run on a cadence. Let's say some like S3 cleanup task or something. You can set up a cron job using cron tab and just have it run every 15, 30 minutes, hour, whatever your schedule is. And then this little diagram I had for this S3 example is, let's say you're uploading a file and you need a behavior to happen when that file gets uploaded. You can actually have a trigger to listen for file upload and then process that event. Done that. It's really great to use Python specifically for the S3 triggers. Just behaviorally, I found it to be a lot cleaner than the Node implementation. So kind of given all that, I want to go build stuff. One more question from the audience before I keep going though. Mark asked, can we use Socket.io with serverless? And the answer is yes, but it's kind of situational, and I'm not going to spend too much time specifically talking about that today. But envision serverless as kind of your backend provider, even though it can serve up your front end through CloudFront. And you could use Socket.io still. There are recommendations for how to use it. The one challenge becomes, how are you going to persist your sockets? And I'll talk about that a little later when I talk more about the gateway restrictions. So let's build stuff, because that's really what we want to do today. So let's talk about how you're going to kind of init a project. So I've done some of this ahead of time to save, but you can just install Serverless Framework by globally installing it with npm, which I did earlier. I don't want to make y'all wait on that. But once that happens, you'll have access to two commands, either serverless, or you can cheat and just use SLS. That's what I like to do. And this will initialize a new project, and it's going to give you a plethora of options here. As you can see, by default for AWS, it gives you, it gives you AWS by default, and it gives you a handful of starter kind of project structures you can use. I'm going to use the starter one for today, but all of the other options, if you're doing some type of work in those capacities or need those types of tools, I highly recommend. I'll show you how to manually do some of the scheduled task and SQS work from scratch, because that's kind of part of today's demo. But I'm going to go from a completely blank slate. Just going to give this a simple name. It's going to create a demo. And next thing it's going to do is, if you have a serverless account and you've logged in the past, it's going to be like, hey, what org do you want to add it to? This is for their serverless dashboard, which is a great way to monitor and deploy things. I don't really want to use it today, and some people might opt in and out of it just pending cost. It is a reasonably priced product, but you might not be in your budget at the time. I'm not going to use it for this personal project, but highly recommend you look into it. This would attach my demo to that, so I'm going to just skip that for now. And then it's going to ask you if you want to deploy, and this will actually deploy into AWS for you. I'm going to skip that for just right now, because I already have kind of where I want to go with this in a little bit in a different directory, and I'll show you all that. But let's look at the code and see kind of what this gave us. Let's actually go into the right directory when we do it, though. Okay, so it gives us 4 files. I don't really need to talk about the get, ignore, or the readme. Those are going to be self-explanatory, but it gives us this serverless YAML that I mentioned before and a handler. Now let's talk about the serverless YAML first. The serverless YAML is going to be the central control point for your entire serverless project. And what it does is it defines a service, which, remember, that's the organizational unit. And then what it's going to do is it's going to find what framework version we're going to use. Now, there's 3 versions of the framework out in existence today. Version 3 just came out a few months ago, and it is fantastic. Highly recommend it. It really simplified a lot of the YAML stuff, and I'll show some examples of what you had to do in the past versus what you can do now in a little bit. But then what's really nice is it gives you this kind of provider information. Now, this is using AWS, and it's using the Node.js 14 runtime. Unless I've missed it, AWS hasn't come out with Node 16 containers yet. So those aren't an available runtime, but they have sunset Node 12. So Node 14 is kind of the standard for doing any operations there. Now, this can be replaced with Ruby, Python, PHP. Again, any of the runtimes that AWS supports, you can do here. And then finally, what's in this file are my functions. And these are all those lambdas that we talked about earlier. So now I'm defining a function, and it's referenced through kind of a path, and then it has to be named. So you can't do default exported functions and have it work with serverless. So if we go look at our handler real quick, it's in the same directory. So this is root based. And then it says, okay, I'm looking for the hello exported function. And you can see here, it's a very simple event that takes in some input as the event and then responds with what looks like an HTTP status code and a JSON body. So the next thing is, well, how do I now test this code? Why is this so much better? And quite simply put is the serverless framework actually comes with some really helpful commands. And you can look them all up using the SLS help command. But the one I'm going to point out specifically is invoke local. And what's really powerful about this is I don't have to deploy this code anywhere to even test it now. So if I run SLS invoke local, and then I use, I know the shorthand, it's function equals, and then function name. What this will do is, as you can see, it actually invoked my function on my machine locally in just a few seconds, or not even seconds, in microseconds. And as you can see, I can now invoke my function locally, which means I can go in now and I can change things and be like, okay, let's change our message to be hello JS Marathon. And we can now run it again. And as you can see, we get our new message that our front end would be able to parse and handle appropriately. So this is great because now we have a Lambda that we can just use. But what's kind of unfortunate is this Lambda doesn't really do anything. It's not attached to a trigger or anything. So unless we had another Lambda that was set up in infrastructure to call this Lambda, it wouldn't do anything for us. So what we're going to do now is we're going to go back to our YAML file, and we're actually going to define our first event. And the way we do that, is we're going to come into our function, and you can see my Copilot is trying to tell me exactly what I want, except that this was the serverless 2 syntax and not the recommended value anymore. So what we're going to do instead, and what I mean by that is specifically this event. So HTTP is the old HTTP event that the framework supported through AWS. AWS has come out with a new value that's a lot cheaper and expedient called HTTP API, which is the recommended path forward. And that is going to change some syntax here. So I actually have to capitalize the get here, and I have to get rid of these 2 values because they don't actually work anymore. And now what I have is a working event, which is super duper handy. And unfortunately, I still have no way to test that. The only way I can test this now is by deploying it to infrastructure. And the way I can do that is I can just do a SLS deploy command, and I'll just deploy it to my dev stage, and my region is going to be US East 1. And if I do all this right, this is going to take a minute. This will deploy, I'll get an endpoint, and I'll actually be able to open this up and be able to do things against real infrastructure in just a few seconds. Excuse me. One thing that I didn't do yet is this actually won't work once I deploy it, and I just realized that, so I'm going to kill my deployment before it finishes. I'm going to get blocked out because CORS is enabled by default. So CORS is disabled by default, so I need to enable CORS. Don't actually do this in a real production environment. Actually set your headers restricted down to your service. But for this demo, I'm going to go ahead and deploy that real fast. And I'm going to answer some questions while this is happening, unless something is really upset at me, which is, of course, I messed up and the whole thing is foobarred because it's already deploying. So if we go over to my AWS account and I refresh, I got logged out. So let's log in first. Ignore all the things. Okay, so when I refresh here, you'll actually see that I have a, should have had a demo. Apparently it did not, and I foobarred the whole thing already. So one problem, don't actually kill a deployment when it's doing your cloud formation, because once the create is in progress, it can't be undone and you have to wait until it finishes and get lucky on timing that. I think I fixed the timing. I'm gonna go answer the question while I wait on this. Jamie asked, are AWS services able to be mocked as well, or does it hook up to the real one? You're beating me to the punch, actually. I'm gonna hold that question until I answer it in just a little bit, but the answer is yes, we will be able to mock them, which is really cool. While this is running, I actually have another little demo just to show off a little bit of power of this thing. So let me go check that out real fast. So I have another template ready to go. Grab this for later. And let me just show y'all some of the cool things you can do with this. I wish that Zoom would not be right where it is. Okay. So assuming I did this correctly, yeah, I did. You can see I actually created a handler using Ruby. And if you look at my serverless YAML, there's a lot more here, which I'll go over, but I've changed it to use the Ruby handler. And I've changed my runtime to be Ruby 2.7. This will work exactly the same as it would have in the other environment with JavaScript, just to kind of show you can use any language you want. A lot of flexibility there. It's kind of a cool little like, oh, hey, I didn't know I was going to be able to do that. So thought I'd share that while we were deploying. And awesome. So now we're actually deployed to infrastructure. I fixed my CORS issue. And so if I go click on my lovely link here and pull it up from the other screen, you can actually see the deployed and active version of Hello JS Marathon from actual infrastructure. And if I go into my AWS account now, I can actually see, here's my demo, hello world. And what's neat is I'll be able to actually see the source code as well as any monitoring. So any execution values, etc. So I ran it once. If anybody else managed to copy that link in the very brief period it was up there, it would show up here. I don't know why there is a good delay on that, but if you actually go to the CloudWatch itself, you can find the event stream and you can actually see, hey, here's my Lambda being run. Here's where it ended, and here's the report on how long it took to run, the memory footprint, and all the amazing things you need to know about your Lambda execution in order to use it later. So I probably don't actually need this large 1024 megabyte instance that I'm using, or 1 gig. I could probably get it down to half a gig, and this function would run just fine. So that's going to be an optimization we'll talk about in a minute. Let me see where I was heading next with this, checking my notes. Starting point. Okay, so we've set up a trigger. We've shown how to test out of the box. Okay, so we're gonna get to Jamie's question now. What's really kind of nice about this setup is it works, but I can only test things. I couldn't actually test the server. There were some downsides to it. So this is where serverless plugins are going to become really helpful. So we'll be done with this demo app for now. And what I have is yep, this is the window I wanted. I have this kind of slightly more advanced version of the demo app already created and deployed. And what I've done is I've added a few things. So we can see our same hello world. We can now see similar provider setup. The one thing I did here is this is referencing my AWS config profile that I named demo that has my AWS key and secret. I'm not going to open that file because I don't want to expose my secrets to the world. But just know that on your file system somewhere, if you set up the AWS CLI, there's a folder, there's a credentials and a config. Inside of that, there's a bunch of profiles. That's how I'm referencing that. So I'm not going to continue typing that command, but I wanted to demonstrate that and where this name came from. The other thing here you'll see is I've introduced two plugins. And I've also noted that this order matters. So I've introduced the serverless bundle plugin and the serverless offline plugin. I'm going to talk about the serverless offline plugin because this is where Jamie's question gets answered. The serverless offline plugin functions in a way that allows you to mock the entire AWS ecosystem with some additional plugins as needed, but allows you to run your entire setup as a local server, like you might with an Express server using NodeMon, or if you're a Rails person, the Rails server. If you're a Python person, I actually don't remember what the Django command is, but whatever their serve command is. So this is going to just serve up your app, let you test things, and it's really fantastic in that it'll let you emulate a lot of things. The other plugin I'm using is the serverless bundle. And the serverless bundle is utilizing Webpack under the hood and giving me TypeScript and ESLint and a whole bunch of testing kind of out of the box. So we go to my package JSON real fast. You'll see I've set up a bunch of dev dependencies. I don't have any dependencies for this project yet, but for development I do. And I've set up the bundle, the offline, and serverless itself. And I've set up some kind of helpful commands here that you might be testing and running at various points. So you can see I have serverless bundle test, great command that the library gave me. And then I also have start, which is the offline start. And that's what I want to demo right now. So if I start it, what we'll see is we get this lovely output from the offline command. And it gives us a lot of information that we might overlook if we're not careful at looking at it. Specifically up here at the top, I want to start with this, which you'll notice that it's saying it's listening for lambdas on port 3002. And then down here, what you'll see is that it's listening to localhost on port 3000. So what happens with serverless offline and with Lambda is it actually runs your HTTP server on one port, and then actually runs all the Lambdas as though they're their own individual server on a different port, in this case, 3002. And that's how you can do some of your local invocation. So if you're doing cross Lambda communication, like one Lambda calls another, you'd be using this port instead of the main 3000 port. Another warning we're getting is just from serverless itself saying, hey, you enabled cores for everything. You might not want to allow every origin to access every single header and method. Maybe don't do that. But what's really neat is now if I go and I look at localhost 3000, I'll bump this up a few sizes. You can actually see that I'm getting my function run, and I'm also getting input from the HTTP event. So I'm getting request context, I'm getting body, getting headers, things you would normally find in an HTTP request. So this is really exciting now because now I can fully emulate the HTTP gateway or the API gateway that Amazon's providing on my local system. So now I can go develop things. And the other nice part about the bundle is it has HMR. So I can, change to say hello JS Marathon again. And I can get rid of that event because we don't need that. And if I refresh, we can say hello to everybody. So nice HMR, nice running of everything. And this just creates a very nice development ecosystem for us. So now we can do a lot of development. So I'm going to pause to talk about what's so great about this. Now, a lot of the people on this call I know are very familiar with AWS Amplify. So I want to compare these two products for a moment. If you're familiar with AWS Amplify, it gives you this auto deployment to the cloud. and it manages the services, does all the deployment, and handles a lot of the infrastructure as well for you. So a lot of the problems we just solved, Amplify seeks to solve as well. The challenge that I think many of us have faced is that it doesn't allow you to do any offline development. So anytime you needed to test a change, you would have to deploy the entire infrastructure just to test that one change. So you couldn't do this rapid iteration like I just demonstrated. And this is a reason we really prefer the serverless framework over Amplify itself. We're not waiting for deployments to infrastructure to validate our change. We're able to just validate it locally, push it up. We might have to do some permission tweaking, but that's an easier to solve down the line problem than actually verifying that a complex algorithm works locally or not. Another kind of challenge that people have with serverless architectures in general, though, is testing. The testing is very much emulated, especially in a local environment. You can really only test using end-to-end testing on deployed infrastructure. And so that's what many people do. They'll set up a Cypress suite or something similar to go and validate their endpoints in production. But what's really nice about Lambda in general is it's highly testable because everything's just JavaScript functions. And so of course we could just use just out of the box, run our test and validate that things behave in a particular fashion. So as you can see, I have my little test handler here, and I can run this and run my whole suite, and it'll do its best to emulate the entire environment, but there will be a couple of little things that don't work. The way environment variables are served, et cetera, are going to be a little different in Jest than they are going to be in the actual deployed serverless. So that's going to be the one kind of downside of this. But generally speaking, it's a much faster development process. All right, checking what was next on the list. Zoom, you keep getting in my way. What's up with that? Okay, so let's talk about a slightly more important topic, which is going to be bundle analysis. So I'm going to go ahead and check out some code, save us a little bit of time. Let me get to right about here. So I'm going to kill my server, and you have to kill the serverless offline server anytime you're about to make a change to the serverless YAML file, because it has to be any changes here have to be picked up by the server, has to do a whole refresh. So that's a big change here. So I've gone ahead and just added a very simple handler here called goodbye. And if we go and look at our function, goodbye is just going to have a I'm going to return a 404 and say see you later. We can again just validate that change, and it's not going to be anything terribly special here, but it's worth just noting that we see it, we have it. We use Postman to test this instead, but I've gone ahead and just used the browser because everything's a GET request. Now, this in itself isn't terribly interesting, and I completely recognize that. So what I want to do instead is I want to show you all a really awesome feature of Serverless Bundle, which they didn't have when it originally came out. And I was very sad. I wrote a whole blog post about it and how I had to basically undo their entire package and rewrite it for myself. And now it's actually just a really fantastic thing that they have as part of the bundle. So they've made it so you can generate these stat files, which is really, really handy. So what I'm going to do is in the bundle, I'm going to give it a value of true. And what this is going to allow me to do is I'm going to be able to run package analyze with the functions. Oh, that's a command and something else I'll show you all. But as you can see, the bundle analyzer ran itself, and you can see I've got a bunch of reports saved now. And I have it in two formats, JSON and HTML. And what this does is it uses the Webpack analyzer. And I don't know why this file is choosing not to load. There we go. And what we now have is we can see our entire bundle size and all the functions that got packaged with it. And this is really handy because it's saying, hey, when this thing's getting bundled, it's going to be a total of 121 KB. and it's going to package this entire file and all of its components. And it's going to do the same for the goodbye function. Now, I look at this and I say, that feels a little large. And part of the reason it feels a little large to me is because of a few reasons. It's using some libraries, which are fine. But more importantly, I think it's actually bundling both functions. And if I actually go look in the serverless folder, and if I go grab my hello zip, I'm going to go reveal it. And let's unzip it. Grab our handler, which it's going to be really hard to read because it's unmapped. Let's see if the maps it any better. It's not. But if I look in here, you can actually see that the goodbye function itself is included inside. You can kind of see it right here, the function code. It's actually included inside of the bundle of the hello, which it doesn't need that infrastructure. It doesn't need that function to exist. And this is just a kind of bundling issue of JavaScript in general that we have to just kind of be mindful towards. So something else I'm also doing is I'm using the bundle individually flag from serverless. I'm going to go ahead and just change that up real fast just to show a slightly different stat, which, as you can see, if everything is bundled together, and this was my real red herring when I was setting this up, is everything is the same size even after. So they're all 121K. And what this does instead is it just packages all of the functions into a single bundle, pushes that up to Lambda for us. So I recommend packaging individually. It'll decrease the amount of memory you have to use per Lambda, which leads to why do you even care about that question? And the reason you care is serverless infrastructures suffer from an issue called cold starts. So this is the other advantage to maybe an old traditional server versus a serverless infrastructure, which is when you're starting up a new Lambda that hasn't been used in, let's say, 15 minutes, because that's AWS's limit, the package actually, or the Lambda itself is cold. So it actually takes some time for it to stand up. And if your bundle is too large, it takes increasing amounts of time for it to actually get warm, and then it can fire your execution. So you could have a delay of up to, I don't know, 60 seconds for your Lambda to actually fire before actually giving a response, which could be really bad in an HTTP environment. So you need to make sure you're keeping your Lambdas and your functions super duper small whenever possible. Now, 121K, not going to break the bank, but I wanted to show you all a demo of how you can now split your functions into individual packages, but then improve the optimization. And so the way I'm going to do that is I'm actually going to change up my structure a little bit, and I'm going to move my handlers into their own little JS files. So I'm going to make a hello. I'm going to make a goodbye. And let's just move some code around super duper fast. So this is the hello function. We can just paste that there. This is the goodbye function. We can paste that there. Of course, I can move my test, but I'm not going to do that right now just for time's sake. But I am going to delete the handler. And what we're going to have to do now is in our serverless YAML, we'll just have to update our reference here. And the way I'm going to do it is it's just going to be handlers, the file name, and then .handler. Of course, I need to go in now and rename both of my function handlers to be their respective handler name. Again, make sure the function name matches the right-hand side, the file name matches the left-hand side. And if I go run yarn start one more time, we'll see that effectively there's no change. We still get both our functions working perfectly fine. And then if I go run my analysis now, just running the package command, what we can go look at is these files. We'll get rid of this one. So this is the hello. Again, it was 121 before. And when I refresh it, hopefully I refreshed it. I didn't refresh it. Let me go just reopen them all the way up. Once I've rebundled them, they're still 121K. That's interesting. I'm surprised they're so large. Goodbye's smaller by about 1K, So I'm a little surprised by the size difference. It might be just I saved some bytes, I saved some, which, we can go investigate this real fast by just saying, all right, here's the zip one more time. Let's go find it. Let's open it up. And then let's just see if inside of this file, we can just detect our goodbye function at all, which you can see there's no 404, there's no see you later. So it actually did eliminate that code snippet, thus reducing the size of this whole bundle. Now, there's some other miscellany in here. I think some of this is actually the Webpack bundler kind of coming in and bloating our package a little bit. And we can investigate that, improve that using other bundlers, but wanted to kind of show some of the advantages of bundle improvements. And I have a much larger example I'll demonstrate. I just want to make sure I haven't missed anything important that I wanted to show you all. Yes, there's two things I wanted to show before I demonstrated that. First off is the fact that we can actually use TypeScript with our serverless bundles. What is this complaining about? Oh, I know what it is. So first off, I want to just kind of checking out some code just to speed things up a little bit. But what I've done in this example is I've created, I've used TypeScript essentially. And what I've done specifically is I've installed the AWS Lambda types as well as TypeScript node. And what this has allowed me to do is now all of my packages can now be, all of my lambdas, excuse me, can now be bundled and actually typed, which will let me know that, hey, this HTTP gateway proxy takes an event, a context, and a callback, which you might not have known if you aren't hyper familiar with all of the different AWS types. So definitely recommend using this, and I'll show an example of what an SQS type can look like in a different example. But additionally, what's really cool, and I mentioned this earlier, is you can actually make your your serverless configuration a TypeScript file. So in here, what you can see is I've converted the entire YAML file that we had before into a TypeScript file. And as you can see, the serverless interface has a bunch of keys, but I now have type validation, which is really, really helpful when I'm trying to add new parameters. So for instance, let's say I want to define the region for my entire project. Of course, I get the regionality and I can autocomplete it. There is a second serverless typed library out there, but unfortunately, it does have some issues with some serverless features themselves. And so I don't actually recommend it, but it did. They did get the type right because it allowed you to do all of the different regions. It had all of them typed out. It's really powerful that way. But unfortunately, it had a couple of small issues with key features of the framework itself. But this is really nice. So let's say I wanted to change my event, for instance. This type can actually tell me all the different types that exist. So let's say I wanted to do an SQS type. And of course, this can tell me what queue, I can name a queue. So let's say a demo queue, and batch and size of 10, that's helpful. What other events are there? Again, I'm just gonna let everything kind of autocomplete. None of that's really helpful though. So I'm not gonna, none of that's quite right. But now we can have a queue, and it's actually upset because the queue name itself isn't allowed. It's expecting, what is it expecting? I'm gonna go look at another example I have open just so we can see it, because I don't remember off. Oh, it's expecting an ARN, which for those that aren't familiar with ARNs, these are just lookups for specific functions inside of AWS. And this is kind of the preferred syntax for naming things like queues. So I won't finish that demo, but as you can see, lots of type completion. It'll prevent you from writing things that don't actually work. TypeScript for the win. I think everybody here probably is very excited about that, except maybe Simone. Sorry, Simone. TypeScript still wins. All right. that is all of my base demo, which is super exciting. So let's jump over. And I created, so I have this other library, and I can go over the details of the library itself in a little bit. But I want to talk about serverless project organization. So I've created this project, which is a serverless with Lambda, or sorry, with GraphQL and multiple microservices. Example, it's super contrived, but it's built with Nx, and it's pretty awesome setup. I put a lot of love into it recently. But this is kind of an example of how you might consider structuring a larger application. So we kind of did the very bare bones basic hello world, set up a Lambda, deployed it, saw that running. That was great. But now let's talk about running kind of more advanced services. So in here, I have these 3 services, and they're all typed with TypeScript, have their configuration. And one key difference with this project is I'm using ESBuild instead of Webpack or Serverless Bundle. There's an ESBuild plugin for those who like ESBuild, and it is super fast. I actually find the startup time for some of these projects is actually infinitely faster than it is in the other environment. So I apologize for the right-hand side. Apparently, actually, I could fix that. I could fix that. Let's fix that. So let's do my example service. And I'll actually get a third window. And we'll do the background jobs. So one issue with developing serverless, as you're maybe seeing right now, is you really have to have all of your services running at once if you want to test everything. This is also complaining because I don't have my infrastructure started. Apparently I can't type. There we go. So let's get our infrastructure started. And so now we have our GraphQL server, an example service, and then over here, we're gonna have our background jobs. And I'm gonna walk you through what each service kind of has and what it's doing. So in this case, this is my public API, and my public API has 2 functions. First off is gonna be my health check, which is just a simple, if you wanna look, it's just a very simple, hey, this thing's working, testing and validating that that's up and running. And the other thing it's going to do is it's actually going to run Apollo server Lambda, which is going to provide a full-fledged Apollo server. And this is Apollo 3, if anybody hasn't seen it yet. This will be a fun little demo for you. And it's running all of that on my local hardware. And then I'll point out some other key things here. So specifically, these values right here. So stage and region are 2 special keys in the provider world of serverless. Stage says, what is the name of this environment? Is this your production, your staging, your local? Is it a development server? This is where stage is defined, and it defaults to dev. What this op stage says is if a value comes in from the command line, the CLI, and it's not, use that, otherwise use dev. And then similarly for region, this is just determining which AWS region we're in. Somebody was joking with me in Slack before this started, like, what happens if US East 1 goes down? I would have changed this to US Central or US West. Quite simply done that, and then I would have been deploying somewhere else. So what's really nice is you're not region tied if you don't need to be. Another really cool thing is there's some other environment variables. So this is actually setting it up so when I deploy to my infrastructure, it's setting these environment variables on my Lambdas. So I don't have to go in and manually set them. If you're not familiar with what I'm talking about, we'll close this window, open that window. Inside of every single Lambda is a configuration window. If you go to the environment variables, you'll see none were set on this demo that we did earlier. But if I come back and if I go to my public API health check, for instance, and I look at its environment variables, you can see that it picked up those values that now I can use in process while I'm running these Lambdas, which is super duper powerful. Additionally, I had to set up some IAM permissions to actually allow this Lambda to invoke other Lambdas. And the reason I had to do that is in my types for my hello resolver, I'm actually going to show you all an example of this Lambda here, the public API, actually invoking a Lambda in my example service that actually provides the value back to this resolver. So now you can kind of see cross-service communications using the Lambda invoke function that AWS provides. In my example service here as well, what I've done is I've created, showing you the serverless YAML first. I actually have two jobs in here. One is just a hello handler, which is that invoke. Notice there's no event tied to it. And the only reason there's no event tied to it is we don't need it to be publicly accessible through an API. We don't need to use it for an SQS. It's something that's going to be invoked by a Lambda in another service. And then in this other example, I've created a simple HTTP endpoint that allows me to generate demo jobs for an SQS queue. And what that looks like is just quite simply, I send a message to a queue that I call demo queue, and it'll just send this message and respond successfully or unsuccessfully, depending on the results of send message. And then hello, for anybody curious, it's a very, very simple handler. Arguably should not have been its own service, but I did it just for example's sake. Finally, I have this background jobs, and this is probably the most interesting serverless YAML I'll show you all today. Most importantly, because it actually defines a resource. So this actually is going to set up a SQS queue in AWS for me called demo queue. And so if I actually go back to Amazon and I open up my SQS, what you'll see is there's actually a demo queue with no messages available or in flight. I can definitely go check out the stats on it, but nothing's there yet. And I had to give this this service the permission to create queues because that's its job. And I also had to use an additional plugin, which is the serverless offline SQS. And that infrastructure command I had to run earlier is starting up a local version or a Dockerized version of ElasticMQ, which emulates the entire AWS SQS infrastructure, which is a really great way for testing things. So to kind of now show off this whole test, what I'm going to do is I'm going to go ahead and just generate a new job. And what we'll actually see is locally, this Lambda pushed a message onto a queue. And off that queue, the message was read and then printed out like the handler says it would do. Now to go for a different example, here's my local Apollo. So I'll just created a query ahead of time just to prep for you all. So it's just going to be a very simple hello world query. And as you can see, it does exactly what you would think it would do. It says hello to you all. And what's really cool about this is what's happening is this service here is actually invoking this other service over here. Now, you might be like, prove it. Okay, well, let me kill my server and run it again and just see that I wasn't able to connect to my service. So this is immediate feedback looping that, hey, I was trying to connect to services, it didn't work. Okay, let me go just reboot that server and it'll work just fine. Something else I will do as well is I'll generate a new job. So server started back up, we got a hello world. I'm going to also stand up the metadata here. And the last thing I'm going to do is I'm actually going to show you all just from my little example. It's on port 9325. Local host 9325. This is the serverless offline SQS ElasticMQ viewer. Or actually, this is ElasticMQ's thing. But you can actually see that there's one message on the queue currently that needs to get processed that's just sitting there waiting to be processed. So you can kind of see the queue is actually being utilized. And then once I reserve my background job, it'll run. At some point, the job will flush. And then on my UI, it's got a nice little socket there. It's saying, hey, there's no more messages. Your queue is flushed. So you can now kind of see all of this different infrastructure all hooked up, and I haven't even connected to a live service in production. So all of this is happening locally, which is just really exciting from the development stance. Now you might be like, well, I want it to run on production. Let me see this thing out in the wild. And of course, who would I be if I didn't actually, prep that demo for you all and actually have it running? So I'm going to kill all these services so you don't think I'm doing some magic. And I'm going to come over, and I have actually stood up my studio over here pointed to my actual Lambda. So if you come and look inside of my functions, I have a public API dev GraphQL that's connected directly to an API gateway. And I can go click on the gateway and it'll tell me, hey, here's the URI that I can now access. So it's going to be that WRB7. So WRB7. So this is my everything's deployed to the wild. I'll change the message here, of course, just so we can see it actually working, and hopefully nothing died. But because I kept my Lambdas so small, even though they were cold, because I haven't run them in, I don't know, over 15 minutes, over an hour, y'all seen what I've been doing. I haven't been running them in the background. They were able to cold start very quickly, and I was able to get fast results. So cold starts can be a non-issue if you set up your infrastructure correctly and if you write your functions in a way that are effective. So that's all good and dandy, but you might be like, okay, well, that's cool. You showed me a very simple API thing. What about that other that generate function? Like, what can I see an SQSQ in production running? And the answer is yeah. So I'm going to go find my example service generate demo job. I'm going to go grab its API gateway because it has a different endpoint. And I'll go ahead and copy the link address. And then it's going to be dev, because that's the environment. And it's going to be generate demo job. I think it was the name of, nope, that's not the name of the endpoint. What's the name of the endpoint? Handy part is I have a serverless YAML file that I can just go look at. It's going to be generate demo job, which is what I wrote. So is it, there we go. It wasn't /dev, it was just /. So now you can see, hey, port's running perfectly fine. And there is a job, it attempted it. If I go to SQS now, my queue will not have anything, but you can see that my Lambda is attached to it. And so if I go into the monitoring, it might not show what just happened, unfortunately. But if I go to, where is CloudWatch? Come on, CloudWatch. Oh, what I can do instead, that's right, I'm doing this the wrong way. If I go to my function called background job dev demo, if I go to my monitor and I view its CloudWatch log, what I should see is from the last, this was, let's see, 11:02, so that was just a minute ago. You can actually see that demo message getting logged out via my Lambda attached to my SQS running on hardware. And that is some pretty handy stuff that you can do with this type of architecture, how you can set it up, how you can monitor it, how you can use your environment variables, and how you can actually set it up both locally and in infrastructure. Now, one challenge is you got to make sure you do these IAM roles. And some people might be like, well, how did you know these were the IAM roles that you needed? How did you know this was the action and the event statement? And part of this is I know a little bit about SQS. I also know a little bit about AWS, and I had to learn a lot of what those resources and services were. And so what I do usually is when I need to look up a thing is I type the service I need, actions, and then permissions. And usually the AWS doc shows right up. I'm able to open it. And there's a great table for reference that you can look at all the different actions you might be able to take. And it also tells you the type of permission on which resource it needs. So in this case, I have the examples of sending a message and getting a queue URL. So getting a queue URL requires that I have SQS on a region, on an account ID, on a queue name. And I've unrestricted this and said, I'm okay if it just accesses anything. probably not the best behavior. You might want to restrict this a little further, because this is saying that now your Lambda role here can access any account in any region, which is not necessarily true. The other thing you have is all the actions, and that's just where I got these names. And they're always just prefixed with the name. So it's the required permission. So get URL is SQS get Q URL. And that's how I've defined that value right here. Looking for other things that I want to mention to you all, some packaging stuff. I kind of mentioned some of that earlier today. But the kind of really powerful thing about the packaging is, as your services get bigger, as you're starting to mess with things, the more this will matter. So I actually have a analyze command in this particular project. So I'm just gonna kind of show y'all what that looks like. So did I break something? No, it's called I can't type. Gotta type the full name of the service. And I'm using the amazing ES build analyzer, which is a little different than the Node.js one, or the Webpack one. And you'll see that this build is actually quite big. It's at 2.3 megs. And it might be like, well, why is it so large? Well, if I look at if I exclude the node modules from my whole build, you'll actually see that my function itself is only about 570 bytes. So generally speaking, this is a very small piece. But then I have my serverless common over here, which is using about 2 megs. And the reason this is using 2 megs is because this is where I'm actually importing all of Apollo. And so that's where my node modules are really living. And you'd have to know how to read this chart to understand where all of that is. And this isn't quite a lesson in how to read all this, but that's kind of where a lot of this behavior is coming from. So you can see, because node modules are not always super efficient, you want to use something that tree shakes really well. And you also want to make sure you're always analyzing how big your bundles are. This is why I keep this specifically is why I usually keep my GraphQL in its own service, because it's already going to be a pretty big bloated service as is, just because of that. And if I'm ever using something like, let's say, the MongoDB driver, I'll also put that in its own service for some of the same reasons, because the data is just really, those modules themselves are very large, very bloated, increase the cold start time, and are things I want to avoid as much as possible. I mentioned one thing earlier I haven't gone over yet, and that would be the serverless v3 parameters. So there's a feature in v3 that I just absolutely would be remiss not to mention to you all, which is the stage params. This is by far the coolest feature that they could have released as part of v3. And let me just kind of tell you why. So inside of this example service, I'm going to point out this custom config that I have. So this is using something, I have this common file that creates a lot of types and self-generated service ports to make this whole infrastructure work. This project itself automatically updates this file, so you never have to touch it, which is fantastic. But one of the really important things is self-references in old YAML style files. And unfortunately, I don't have a YAML style here, so I'm going to go switch back to our little demo here. And I'm going to just undo everything. So back in the day, people used to write things like custom parameters, and they would have done something like dev, and let's just say they wanted a different region per environment. So let's say you wanted prod on US West 2 for whatever reason. As an example, I just realized I'm not even on a YAML file. Let me go open up an actual YAML file. And that way we can actually demonstrate this properly. So creating that custom key, and inside that custom key, I'm going to just copy and paste all of this and get rid of all of the JavaScript syntax, go back to just pure YAML. Some of you might be like, what is this YAML thing? Do I really need to learn YAML? The answer is no. You can use TypeScript, JavaScript, or JSON, but YAML is a preferred option for a lot of DevOps people out there, and they'll be like, yeah, it's amazing. But in the past, people used to have to do something like this, and the way you would reference that value would have been self custom parameters dev, or it gets even worse. You would have to do self provider stage region. So this used to be the syntax if you wanted to set a custom region, so to speak, which is really, it's kind of an obnoxious syntax if you look at it. And it's not something a lot of people like. So what happened in Serverless 3 and is amazing is they actually made it so you can set up your environments kind of like this with provider, and you can just say, okay, I want this to be US East 1, I want this to be US West 2. And instead of this entire block of syntax, all you have to do now is run the param syntax, which now references this parameters key with the dev and prod keys whenever that's the stage being used. So now these are defaulted, and that old archaic terrible syntax can just go away and you don't have to use it anymore. And quite frankly, my favorite feature that came out in V3, I will die on that hill. There's a lot of other cool stuff that I recommend checking out. This announcement is super duper fantastic. I highly recommend reading it. They also made some serious CLI improvements, etc. But that's about it in terms of serverless, the structure, the projects. Only other thing I'm going to do is I'm going to make this I'm going to shamelessly plug this project. So I have this project I've been working on for a very long time, and I call it the Serverless Microservice GraphQL template. But what it is it's a serverless microservices architecture monorepo setup with GraphQL. It uses Index workspaces. It's based off the work by this lovely person here. Could not have done it without them. Also had some serious help from some of you all figuring out a couple of little edge case issues. But this is something I'm super proud of, because if you're like, I don't really want to like know any of that serverless stuff that you just explained, I just want to like build functions and do things, like I want to do the absolute bare minimum of serverless, you can actually use this template today. You can get rid of add services however you please, and you can just run pre-configured commands to set up new services, deploy the services, etc. It's really handy because I'll just kind of do this little demo. Actually, what's my let me stash that real fast. So like I can actually run a workspace generator that I made. Yarn workspace generator, and if I want to add a new service, let's say it's a test service for demo sake, what this is going to do for anybody who's using it, there we go. I don't know why enter has to be hit twice sometimes. Still figuring that bug out. But you get a bunch of services created, and what it does is it scaffolds out a brand new serverless service with all of your configuration that you need and a simple health check that you can then go in and reconfigure however you please. And it sets up a lot of the serverless file so you can just utilize it as needed. And then additionally, it registers the port into your test service here, or into your ports. And so when you want to run something like, I'm going to go to my invoke from the hello resolver. So this takes in a service name. And so now you get the nice automatic type completion with that new test service available to you. Even though it wouldn't work in this case, it will still resolve for you. And it's very handy like that. Handles a lot of port resolution, other kind of behind the scenes mechanics for you. Okay, I just did a lot of talking. I'm gonna go see what questions you all have, / answer any questions you all have for me. Did I miss any from earlier? Jamie, just checking. Did I answer your question about mocking the services? Cool. And then there was a question, Alan, did I get your question about mixing the languages? You kind of see how you would do that now? Oh, actually, I think he had to drop. He had a call. I know about that. I hope I did. But for those that are like still unsure about that, if you wanted to use a different language in a different service, you would have to structure it kind of like these services where background, example, and public could be JavaScript, but test would have to be all Ruby. So you have to, it's all one language per service. On the queue example, does the SQS have to be in a central serverless file? Could you elaborate a bit more for me, please, Nacho?
Yeah, sure thing. Maybe if I speak it will be more clear. So in that example, you show several services that were using the same SQS queue, right? Mm-hmm. The question is more when you are defining that SQS for serverless to deploy it and create that infrastructure in the AWS, does that needs to be in a central serverless place, or you can define it multiple times and it will only create it once and use it for everyone?
Great question. The answer is it does not have to be centralized. It could be distributed. I don't recommend it though, because in a larger ecosystem, you're going to want to control where all your infrastructure is defined. And so it's only defined here in the background job service, because if I had to define it every single location, then every single resource needs to know about it directly. And there's no sense in extracting it away out of that service. So if you have one single, I mean, again, this is a very small application considering what it is. It's intended to be a template. In maybe a smaller application, what you might do is have a single serverless that controls the entire infrastructure for everything, in which case you don't have to worry about one service defining the queue, another service consuming it. I did that because I think that's the better way of structuring, but that's just my opinion.
Awesome, thank you.
Yeah, great question. I guess this also brings up a great other question, which is, what about other AWS services or other triggers? So I very simply shown SQS triggers and HTTP API triggers, which are very simple in the scheme of things. What happens if you wanted to use SNS, SES? SNS is the notification service, SES, the email service. If you wanted to use Fargate, the answer is there's infrastructure and documentation for all that. And I'll actually jump into that kind of quickly. So if you come to the serverless.com website and go into the framework overview, I want to do the learn more. I want the docs. Let me have the docs, please. There we go. So if I go to the docs, what's really helpful for anybody who's exploring this is search is always a great thing, but knowing kind of how the site's structured is even better. Specifically, you'll see there's user guides for how to do certain things, but then there's also provider reference guides. And these provider reference guides are super duper important. Specifically, I'm doing everything with AWS, but if you look, you can see all of these different service providers that you can go look and be like, oh, I want to use Cloudflare workers. And it's like, okay, well, here's all the CLI and how you'll be able to use it. And here are the events it provides. So the Cloudflare workers only support HTTP events. And so this is their syntax and how you would set them up. And that's kind of the guide and how you would do all that. I was using AWS though. And as you can see, my event list is significantly larger. So I have things like HTTP API versus gateway. there is a WebSocket API. Mark, you asked me a question earlier about sockets. Here's the one problem with sockets in a serverless environment and why I recommend using a socket provider. The API gateway in AWS has a 2-hour limit on sockets, but more importantly, Lambdas have a shelf life of 15 minutes. So you don't have a persistent server API client connection going all 3 directions. So if you want to use something like sockets, I actually have this documented in my fun little project here. I want to turn on subscriptions. There's this great library out there called GraphQL and Lambda subscriptions. And this lovely gentleman created a project that allows you to use the WebSocket protocol with GraphQL and Apollo Server through serverless. And the trick that had to happen is it has to use DynamoDB triggers or some other event listener to basically consume events and then republish those back to the API gateway in a specific way. So there's not a great like socket implementation in the AWS serverless ecosystem, but there's a way to kind of go about doing it if you know the tricks. If you're doing sockets, I don't recommend this infrastructure. It's not, if it's like the pinnacle of your business, it's not a great solution. There's other great services out there like AWS AppSync, which you can actually use with serverless, which maybe Dario will tell us all about that at a later date. But you can use AppSync with serverless and deploy that, and AppSync has its own socket manager, which is pretty fantastic. But as you can see, there's a bunch of different events. The other thing here that's worth noting is schedule. I mentioned cron jobs much earlier. And as you can see, you can actually just schedule cron jobs using either cron tab or a rate function. And these are fantastic for keeping Lambdas warm. They're also great for just doing random activity on different services you're doing. So if you need cron, you have that. If you need to set up some CloudFront, highly recommend looking at this. I didn't mention this earlier, but you can actually serve and deploy an entire Next.js system from Lambda. Former coworker of mine did it. It was a really great setup. I don't know if I would prefer it over Vercel or Netlify, but it's definitely something worth looking at. But there's all the responses and examples here. There's some documentation out on the internet about how to do it. Cognito pools, if you're using those for authentication, set up on how to do all that. DynamoDB streams, you name it, you can absolutely see every single option that's out there. And I recommend just kind of clicking through when you're trying to figure out something. I mentioned earlier the API gateway versus the HTTP API. You can read more about it here, but there's 2 versions available through the gateway. The other thing really worth noting about as well is, and I forget if they have it here. Let's see, serverless framework plugins. There we go. Plugins are amazing, and I really, where's their list? This talks about creating them. Let me see if there's actually a list anywhere. Plugin repository. Here you go. There are so many amazing plugins out there. I really recommend checking out most of them. I'll tell you some of my favorite ones that exist right now because they have helped me infinitely, and I'll point out a couple that I would avoid for very specific reasons. First off, serverless offline. I showed it during the demo. I live, die, and breathe by this plugin when I'm doing serverless development. If you're not using it and doing serverless, start using it today. It'll really like 10x your development lifecycle. Serverless Webpack is an alternative to serverless bundle, but I've been using serverless ESBuild, which I also highly recommend. All 3 are great, work out of the box. I think ESBuild's got a slightly faster offline start time, but none of them really improve. There's not a huge advantage Webpack versus ESBuild for deployment. Serverless Domain Manager, if you're trying to actually set a domain against your public API like I have, this is the best way to do it. We've used it on a couple projects internally. I highly recommend it for first-time use because it makes it seamless. You don't have to understand all the intricacies of Gateway. They kind of just bundled all the things up for you. I would avoid the serverless.env plugin if you're on serverless v3 or later. Reason being, serverless comes out of the box with .env support, so I just don't recommend it. It doesn't quite work. For serverless IAM roles per function, this is one that somebody actually pointed me to. You noticed in our kind of demo here, I've been defining IAM roles at the top level provider. Maybe you want to be a little more restrictive on what people can and can't do on a per service basis at the function level instead of at the global level. This plugin will let you define those rules on a per function basis. Pretty neat. Again, check it out, see if it's something you want. It might be overkill for your particular project. Serverless DynamoDB local. If you are doing anything with DynamoDB, you absolutely should be using this plugin. It is amazing. It sets up Dynamo for you locally, runs it, lets you do any interactions, create streams for you. It's everything you could need for that. There's so many more in here. There's offline S3. Here it is, serverless S3 local. There's local SQS. But one thing that I highly recommend, and this is a gotcha to the framework, is be careful in which order you install plugins. So I'm just going to walk through mine. I have the ESBuild, the S3 remover, which if I put any artifacts in S3, this will just clean up after itself. ESBuild for my bundler. The analyze bundle plugin has to be defined after ESBuild for it to work. And then the ESBuild itself has to be before serverless offline for offline to do its job correctly. If you use DynamoDB local, it has to smash right. It would go right here. This would be the Dynamo. I think it would look like, I can't type today. And then for the offline plugins, look at the documentation. It might say define this before offline. It might say define it after. SQS specifically goes before. I think S3 goes after. Again, read the docs. They're all very particular. And if you don't do what they say, you're just going to be scratching your head trying to debug for hours and not understanding what went wrong. Any additional questions? Oh, I just deleted too much. Well, fantastic. Well, thank you all for joining us today. We hope you join us at our next JavaScript Marathon, and we hope you all have a lovely rest of your day.